Hello, everyone. I'm Sonia Sarao, VP of Product at Groove, number one sales engagement platform for enterprise companies using Salesforce. I'm also the San Francisco chapter co lead for Women in Product, the organization and the community that has had the most impact in my career and in my life. Through Women in Product, I found people, resources, and tools that have enabled me to build better teams, better vision, strategy, roadmaps, and ultimately better products. That's why I'm thrilled to be your host for Refine Your Toolkit stage. But before we get started, I want to take a moment and thank our sponsors without whom this event will not be possible. All right, let's get settled in. Turn off those annoying work-related notifications, be fully present and be ready to use the app to ask questions, share inspiring quotes and put those tweeting thumbs to work. During this session, up-level your technical skills. We have three wonderful speakers. First on stage, we have Surbhi Kaul, Head of Product, SDN, Juniper Networks. Surbhi is an accomplished product leader with immense strategy experience in both B2B and B2C companies. She's passionate about building AI, ML-driven consumer and enterprise products and utilizing data-driven models to achieve customer success and has built and led product and engineering teams at technology icons including Google, YouTube, Netflix, Cisco, and now she leads Juniper's enterprise data center business as head of product for network virtualization and SDN software products. Surbhi will also share her expertise with you during our next presentation, AI ML Concepts for Success in Product Management. That hopefully will help us articulate value propositions of machine learning in our products. Please join me in welcoming Surbhi Kaul to our stage.
Hello, everyone. My name is Surbhi Kaul, and I'm a Senior Director of Product Management at Juniper Networks. I'm really excited today to share with you AI/ML concepts that I've learned over the last decade working at companies like Google, YouTube, Netflix, and Juniper, and hopefully you can take these learnings to help improve your products as well. Let's get started. AI/ML is everywhere. Let me share some of these commonly used products and tools in our daily lives that you might be familiar with. I was fortunate enough to work on many of these products as PM lead. First and foremost, let's talk about recommendation systems. Most of the media platforms that you use, like YouTube, Netflix, Hulu, Amazon Prime, all of these use features like Watch Next, recommended videos for you, and autoplay features which immediately start playing the next video when the first one finishes. And the idea is to keep the users on the platform for as long as possible. In fact, watch time is one of the prominent and leading customer metric of success of these systems. All of these platforms use machine learning to engage users. Next is something that you all might be familiar with and get inundated with on your day-to-day lives, which is spam emails. And over time, the email programs of today learn how to detect and separate out spam email from your email folders. And this is again the magic of machine learning. Next, let's talk about some surveillance cameras, which use facial recognition, pattern recognition, pattern matching, and all of these are machine learning algorithms that alert you when you have a visitor, when the doorbell, the Nest Cam, or the Ring doorbell rings, and you know if it's a package delivery or it's somebody that you should get up and open the door for. Last but not the least is my favorite segment of smart speakers. And I was fortunate enough to work on Google Assistant and Google Home in my time at Google, where we spent a lot of time improving the query response and false negatives that get triggered when you have the smart or the wake up phrase called OK Google. So these are some examples that hopefully give you an idea of how these use cases and products are using machine learning to make our lives easier. What I will talk about today is AI/ML concepts, the types of problems that are addressed by machine learning, and then what kind of models are used and applied to address these problems, and how product managers can bring their skill set to add data and metrics value add to these products, And last but not the least, we'll touch upon privacy and ethics in AI ML, which in itself is a huge topic and we could discuss about it for an hour, but I will just give you a little glimpse, and then if you're interested, we can talk about it during Q&A session or later on post this session. So if we look at the history, in 1959 is the first time when Arthur Samuel programmed a computer to play a game of checkers, right? This was the first implementation of machine learning where a computer could play the game and eventually beat Samuel in the game. We continue on the journey, and in 1997, IBM's Deep Blue defeats the chess champion of that time, Garry Kasparov, in a similar style where the machine is taught to play the game and can then on its own make the moves and be able to beat somebody in a game. And then in 2016, while I was at Google, there was a huge face-off between man and machine. This was a much watched and much awaited event. And the thought was that people assumed, the scientists thought that we could not get to this point for at least another decade, but we were able to, where AlphaGo was able to beat the champion at that time, Lee Sedol, in the game of Go. And you might think that, we are just progressing to more and more complex games. However, the game of Go adds a completely new dimension, and it's much exciting news for the world because it is said that the number of combinations in the game of Go are more than atoms in the universe. You cannot really program a machine to understand all those combinations and options. You have to teach the machine how to play the game and be able to use strategy and make decisions by itself. So it's a field of study that gives computers the ability to learn without being explicitly programmed. That's the first definition of machine learning that we see in 1959, and it's still valid and used in the field quite a bit. Let me also clarify, when people talk about artificial intelligence and machine learning and deep learning, there is a lot of commonality between these terms, but still it's important to understand what is the difference. AI and ML are used synonymously, but there is a slight difference which I want to clarify here. So artificial intelligence is the science of making machines perform tasks that normally require human intelligence. So you're teaching a computer to act like a human being. That is artificial intelligence. So if you look at robotics, autonomous vehicles, these are all machines that are acting like a human would, whether it's driving like a human or moving pieces or working in a factory like a human. All of these are considered artificial intelligence components. Whereas machine learning, which is a subset of AI, is actually ability of these machines or programs to make decisions without being explicitly programmed, right? So examples of that are speech recognition, image recognition, language translation. All of these use cases actually use machine learning. And then we have deep learning, which is a further subset of machine learning, and it uses neural networks to solve more complex problems and iterative approaches like time series prediction, natural language understanding, etc. Now, one would wonder that if we have been looking at AI ML since 1959, why is it now that machine learning has become so ubiquitous? Why do we see more and more products leaning towards and using artificial intelligence and machine learning? And the reason is this. Over time, the compute and storage resources used to make machine learning models have become easily available. They have become more affordable. So if we look at the program AlphaGo, it used about more than 1,200 CPUs and 150 GPUs. And this would not have been possible to have this kind of capacity available about 10 years ago. So that is one of the big reasons. Another reason is the ability to provide these resources through cloud computing. So startups or any companies that are looking to use machine learning models, they can very easily stand up resources, spin up resources, whether it's compute or storage, and be able to run these models. And then if they decide that their use case is not suitable and cannot be solved, they can quickly spin them down, right? Then the next reason why we see the democratization of AI is because companies like Microsoft, Google, they have made AI ML platforms and APIs available to enable the quick advancement and adoption of these technologies. Now that you have some understanding of these definitions, let's go a level deeper to see how we teach these machines to make decisions and make the recommendations that we have been talking about, right? To be honest, this is the value add that typically your engineering and data science teams will bring to the table. But as a product manager, I feel that it's very important that you familiarize yourself with these concepts so you can have meaningful conversations and dialogues with your engineering teams when you're trying to solve these problems, right? So first, let's look at a basics of a machine learning model. What are the components and what is the value out of those? So if I look at a very typical model, the first thing that you need is data, right? It's the most critical thing that is needed for building a successful machine learning model. You need data to train the model, as well as save some portion of the data for the feedback training, right? And then there's a machine learning algorithm that, like I said, your engineering and data scientist team will own and will build that. However, what data is fed into that model would be something you will participate in, because you will create the features that are coming into that data and the metrics that are needed for building a successful model. So now with that, using that machine learning algorithm, a model is built. And then taking some of the initial data that you had, this model is trained further, right? It's iteratively improved by using this test data to make sure that it's making correct recommendations that you would expect. And then when an new application comes in and it puts in a query into this model, the output is supposed to be very accurate and close to what you expect, right? So let me give you an example. Working at YouTube, cat videos and cat pictures are become part of your vocabulary. So I'm giving you an example of a model that is being created to be able to identify the picture of a cat, whether it's a cat or not. So first what you would do is you would take lots of pictures of cats and dogs and maybe other pets, other household pets that you feed into this model, right? This is your training data to begin with. So if you do not have any data to train your model, you cannot really build a very successful model. So the more data you have, the better. Now you're not telling the program what are the specifics of a cat. You're just giving it all this data and letting the model learn on its own what does a cat look like versus a dog or a bunny or any other animal. And then it builds the predictive model, right? This is a prediction model that has been built where when you bring in the new data of a picture of a cat and say, is this a cat or not? The output would be clearly able to identify whether it's a cat or not. That is the value add of machine learning, right? This is machine learning at play. So most of the times, with a high probability, it will recognize it, but there will be times when a human eye can decipher when it's a pet or a cat, but for a machine, it might not be easy because it's an outlier in compared to a complete picture of a cat. Now let's go into the details of what types of machine learning models exist. Most commonly used machine learning models are classified in supervised learning, unsupervised learning, and reinforcement learning. You will hear these terms used pretty openly by your engineering team, so it'll be good for you to familiarize yourself. Let me give you the details. Supervised learning and unsupervised learning, as the names dictate, is something we can associate with in post-COVID times where education system has moved to homes and online and has a concept of supervised and unsupervised learning as well, where in supervised learning you have more of an instructive style of teaching, or in this case, instructive style of teaching or machine learning model. So you give it a labeled data set to train the model, and input as well as output of this data set is labeled. And there are two main types of supervised learning algorithms that are used to solve problems. One is called the classification algorithm that predicts more discrete values. So the example I just gave, cat or not cat, this is a discrete value algorithm and a classification type of algorithm. And another example, earlier we talked about an email being spam or not spam. So over time, you're giving your Gmail or any other kind of mail program the ability to identify what is spam. And when you give it a lot of historical data of what you have classified as spam in the past, over time it starts recognizing what are the various features that are making it more of a spam email. And so over time, the model will start detecting the spam itself and diverting all of that to your spam folder so you never have to see those emails. Then the other kind of supervised learning algorithm is regression algorithms. And these are used more for continuous values generation, right? So whether it's salary data, it's not discrete. It's not that at one level for a particular type of job, you will always have that salary. It's a range, right? And similarly, home prices, things that the sites like Zillow or Redfin use this kind of data to be able to determine what is the price range of a house. Now here I'm showing the example of salary against age, and I will come back to this example later because it becomes pertinent when we talk about biases in data sets. All right, so that's supervised learning. Now let's move on to unsupervised learning. Just as you would expect, here the data set is, that's right, it's not labeled. So in supervised learning, we give a very, very clear dimensions of the data, and you classify your data very well before you feed it into the model. Here it's not so. You just have a large data set that you feed into the model, and then the job of the algorithm is to find the correlations, right? And create those classifications. So for example, if I look at the same kind of model where I'm creating a program that will identify whether the input is a cat or not, you're here giving it lots of pictures of various house pets. It could be cats, dogs, bunnies, but you're giving completely unlabeled data. And then the algorithm and the machine learning model itself would classify it into here, what we are showing it as cluster 1 and cluster 2. And when the new input comes in, it'll be able to say, oh, this belongs to cluster 1 or not, right? So you may not be using the same label that you had been using, but you're getting this right outcome. So this technique is called clustering. As you can see here, your raw data comes in and the algorithm takes all of that information and automatically puts it into clusters. Some of the examples of unsupervised learning are fraud detection and cybersecurity, where you don't always know exactly what will be served to the model, because in cybersecurity we see attacks that have not been seen before. So this makes perfect sense. Reinforcement learning is another kind of machine learning algorithm and model that is used, and it typically uses reward and penalty mechanism to train the model. And this strategy is used to improve existing models. So for example, robotics, recommendation systems, and AlphaGo are examples where reinforcement learning is used. This is the topic that is closest to my heart, and I feel that this is the crux of what a product manager should focus on, is talking about data and metrics. And if I look at what is the value add of product leaders, one of the things we have to answer and address as product managers is, first and foremost, what is the problem you're trying to solve, right? You have to ask that question. What is my user's pain point? What model am I building to solve that pain point? And once you determine that, you have to see if you have the right amount and right type of data to be able to build a model to solve that problem. Now, whether or not you use AI ML will depend a lot upon this, upon the ability of having good, clean data to train and then build a model. So if I look at companies like the FANG companies like Google, Facebook, Netflix, etc., they have a lot of user data that helps them build and iterate models very fast and even solve new problems by using or utilizing that data. But let's say you have a startup or you have an enterprise non-consumer space, it's a little more challenging, right? That is why you do not see a lot of solutions in enterprise space, because customers may not be willing to share or part with their data for helping a company build a model for their enterprise customers. So knowing when and how to use data is important for product managers. Sometimes you can even crowdsource this data or purchase this data. So there are options, but it's the trickier part of machine learning. And then the last thing you have to ask yourself is, do you know how you will measure success? What are the metrics that you will utilize to measure success of your model? And let me give you some examples there. So if you're building a media and retail recommendation system that we have been talking about, in media, for example, when you have recommended list, if a user is choosing from that recommended list, that means you have built a good model, and that is your success rate. And if they click through it, by selecting that, then you say, okay, what I recommended made sense to the user, clicked with them, and they were consuming that. That means I built a good model. Similarly, in the retail space, if the recommended list was selected and added to the cart or even completed a purchase, then that means your recommendation system of what you suggested to the user is good, is right, and you will use reinforcement learning to train your model to surface more things like that, right? Let's look at the example of Google Home or any smart speaker. And the idea is in the conversational AI that you're using there, what is a way to measure the success? One could be false positives. When you do not use the wake up phrase, but the speaker comes alive and starts listening or recording your conversation or query. And this has been a huge challenge, huge privacy concern. And so this is one of the trickiest ones in any smart speaker that we have to be wary of as product managers. Next one is query success. When the query is finally uttered and the smart speaker is able to take that query and get a response, if that response is accurate, that determines that your query is successful and you do not have to, repeat it. But when I was doing query analysis at Google, so often I would hear a response to a query, but then the user would ask the same question a little more slowly with a different intonation, making it very clear that the answer or the query response that we gave, that was being served by Google was not accurate. That's why the user is not satisfied and asking again. So that is not a successful query, right? Next, in healthcare, imaging and diagnostic, this is a huge field. Again, because of HIPAA compliance, we may not have a lot of data to build the models, but whatever data and modeling we have been able to do, you should be able to measure the success rate of that. And it could be accurate detection of disease. That could be one metric you would look at. Let me give you a little bit of explanation of how you would go about figuring out if AI and machine learning is the right thing for you, for your product. So just like you build a business model canvas, you have an AI canvas. And I've just taken something from the net. If you just Google AI canvas, you'll get all kinds of models that you can use to assess whether, what is the value prop of your product and if AI ML can be used for that. So creating this kind of model will help you understand if the strategy, business, or available things can be used to build this model, right? We can talk more about this model during the Q&A. Lastly, I want to touch upon AI ethics and privacy before I end this talk. And I want to call out a few things that I would love for our product managers to be aware of, right? And let me give a disclaimer. When people talk about AI ethics, and they are a lot of times talking about moral behaviors towards these robots, right? Towards these AI entities. How should they be treated? What kind of rights should they have? And while that's a very interesting topic, that's not what I'm talking about. I'm talking about the data that I was saying, that you have to gather some data to be able to build your model. What you have to be aware of, that a lot of data that we have out there is fraught with biases, right? If I look at, for example, job and salary data, right? And I want to create a model that can tell me for a such and such a role, if I have a female leader in a role, what kind of salary, what kind of package, what kind of benefits. If I determine that using historical data, I will just carry on the biases that have been in this data in the past. We know that, the gender gap that exists in our salary data, that will just be propagated. And any model that I build will have the same challenges, and I'll continue to propagate that problem through a solution that I build. So we have to be aware of the biases that exist and try to figure out how you can eliminate those. And there is something called data pre-processing that you would do to eliminate some of those bias. Then lack of representation in data is another challenge, right? If your data is very limited towards a certain class of people or certain type of data, and I'll give you again examples of pictures of animals. If you only have pictures of cats and dogs, then if you go to Google Photos and try to look for a picture of a horse, but you have never built it into your model, you will not be able to see those pictures and those data. So you have to see that your data represents all various categories really well, has to be inclusive to be able to build a good model. Similarly, financial institutions using risk analysis, any bias that has existed in how loans were given out in the past will continue to propagate in our existing solutions. Same thing can be said for judicial system as well. Now, the next thing I want you to be aware of is PII, right? Personal identifiable information. This is a huge challenge for companies that have all kinds of data available about users, and they have to anonymize this data to protect the identity. And there have been best practices recommended through GDPR that should be deployed. And so just be aware of that you should not be using as much as possible PII to be building your models. You should anonymize and generalize this data to get clarity. So in the end, I would like to close by saying that AI ML is an extremely powerful technology, right? And it can be put to amazing good uses. However, just like any other superpower, it comes with its set of responsibilities and we should take it seriously. And as product managers, it is in our hands to make it or break it. I hope you found this talk useful and will be able to incorporate some of these learnings into your products and solutions. This is a vast topic, so 20 minutes does not do justice to it, but I'd be more than happy to answer your questions and also connect with you on LinkedIn to be able to help you and support you in any AI/ML questions for your products as well. Thank you for your time.
Thank you, Surbhi. Next up, please welcome Shanea Leven, CEO, CodeSee. Shanea is a Silicon Valley product manager with specialization in cutting-edge consumer technology and developer product platforms. She is the CEO and co-founder of CodeSee, with over 10 years of experience leading teams and delivering high-quality and innovative products for consumers and developers at successful companies such as Google, eBay, and Cloudflare. Shanea is passionate about entrepreneurship, and I can vouch for that because she's one of my really close friends from Women in Product, and I have seen her in action. She has started her own company through which she has gained firsthand experience as a small business owner, way earlier in the game before she's founded CodeSee, which she's now leading. Shanea will share her experience with us during our next presentation, PMing a technical product when only engineers know. Let's learn how not to feel like an imposter and truly own our important role through this session.
Hi, everyone. Thank you so much for joining PMing a technical product when only engineers how your product works. My name is Shanea Leven. I'm the founder and CEO of CodeSee. And in 2015, I was working at Google as a program manager. And I loved my first few years of product managing programs for developers. Even though my title at the time was program manager, I thought, this is it. Product management is exactly what I want to do forever. I loved being able to have an idea, take it to fruition, and then have it go on to have a meaningful impact for a large number of people. But when I went to go get the title of product manager, I hit a wall. People over and over again continued to tell me that I was technical, but not technical enough. And after trying for years to get the title of product manager, I felt extremely frustrated and found that there were very few doors open to me. At one point, it seemed like my time had finally come. After passing 5 internal transfer interviews for a PM role at Google, the hiring manager said, "We love you as a PM," and I was so excited. 2 days later, when I asked the hiring manager to begin my transfer process, he said to my face, "The team loves you, but you'll never pass the technical ladder transfer interviews, and we're going to give your job to someone else." My one insecurity that I wasn't technical enough had again manifested itself in human form and was standing there in front of my face as a 5'10" lanky guy with all of this power. And so I did the only thing that I could do. I ran out of the Google building, crying profusely in a grassy corner where hopefully no one would notice. And that was it. That was the last straw. I thought, you've got to get this under control. You see, this moment was so hard for me because this was not my first attempt or my second or my third to further my technical ability. And I've been growing quickly, but I was also struggling with major imposter syndrome about my technical abilities. For 4 years before, I had given up a job in Google search because of my technical insecurities. And many of my other friends and colleagues have shared this same insecurity, so maybe you can relate too. Determined to not live with this insecurity, I lay out my options. They were: 1, spend 4 years getting a computer science degree; 2, get a master's degree; 3, go to a boot camp; And so I asked myself, what was the fastest way to never get labeled, you're not technical enough ever again? So after doing some research, turns out I can get a second bachelor's degree, which would only take 1.5 years, and I was sold. So I decided I'm going to get this computer science degree while I was working at Google, and it was going to be great. The first 2 or 3 classes, Intro to Programming 1 and 2, were easy. I've been teaching myself to code for years. But then 3 months into the program, I had to take this discrete math class, and it broke me. It broke me in a way that Boolean logic should never have broken a fully formed human. So you see, all of this time, I thought that I was really good at math. I skipped a grade in math. And it turns out that there was this thing called a math proof, and you're supposed to learn in geometry, and my Maryland and Virginia public school system conveniently left that out. And this was one of the hardest educational experiences of my life. My measure of success was how little I cried each day. And nevertheless, I persisted, because what I didn't realize at the time was that even though I felt like I was experiencing all of these setbacks, I grew a lot. I was really being set up for the next phase of my life. And I had a lot of knowledge already, but I had gaps. And because I was learning these skills while working full time, I was ultimately able to fill these gaps and connect the dots a lot faster than I ever thought was possible. In the end, I got the degree. Was it hard? No. It was excruciating. But was it worth it? Sure, of course it was. Only 6 months into the program, I had landed a senior PM job at eBay. And after all of those rejections, not only did I get the PM role, but I actually got to skip junior and go straight to senior, along with tripling my salary. I was also given a ton of opportunities that my CS less counterparts weren't given. And in a year, I took 7 separate products from ideation to launch, and that gave me enough experience to propel me to an even higher level of product leadership positions in just a few short, but very tough years. I went on to become a director of product at Cloudflare and a senior director at Docker, senior director of product at Docker, and most recently a VP of product at a developer-focused startup called Lob. Now I'm the CEO of a developer tools company called CodeSee. And the acceleration of my career that came from the time spent furthering my technical abilities was really indescribable. It was one of the most powerful launch pads that I can imagine. So I want you to walk away with how much value it can add for you. Sure, it might be hard, but it's worth it. And I want you to know, why it matters and what you can do about it today. So why is this important? At a high level, it's important because a lot of jobs say we want you to be technical. But at a deeper level, it will make you a more powerful PM because it will enable you to speak the language of engineering. And in doing so, you'll be able to make better trade-offs and serve your users better. At eBay, I was the one to tell my engineers how they could make an MVP of a feature that we could test that would only take 1 month instead of building a full featured product that would take 6. Since I knew the requirements and I knew how the system looked, I knew the shortcuts that we could take architecturally and still have a successful feature. So now I like to zoom in a little bit and share the power that comes from being able to think like an engineer. Normally, PMing technical products, only engineers know how they actually work. And this is a problem because often there's a lot of critical information that's locked in an engineer's head that would be incredibly helpful for us to know. Then we end up speaking very different languages with regards to what's needed, what's possible. That leads to miscommunication and a lot of wasted time and energy. And the language engineers speak is based on large amounts of information about coding, theory, the system, context, and essentially building their own mental models. That mental model that they build is then crammed into their heads. Once it's in there, it cannot be shared and it cannot be reasoned about unless they tell you. But as a PM with technical ability, you can have your own mental model. You can have the context and the models in your head too, and then you can all be on the same page. So how can you build your own engineering mental models? Let's start with understanding how an engineer gets this information in their heads in the first place. So just to level set, it takes engineers 3 to 6 months, and in some cases 12, to get a specific company's system into their heads. I'm sure you've all seen when you hire a new engineer on the team and it's 3 to 6 months until they're onboarded or until they are actually productive. So what are they doing all of that time? They are reading code one line at a time. They're building a database of smaller problems. They are imagining the system, all of its inputs and outputs, i.e. data, and they are imagining if you make this change, what other pieces of the entire system will be affected. You see, you build up smaller problems that combine into larger problems over years, and that until you are able to be responsible for an entire system. That's what takes a ton of time and effort. Now, as a PM, you don't need to know all of this low-level minutia, but knowing it gives you a bit more insight into what's happening. So as a PM, you should focus on imagining the system and all of its inputs, outputs, and the data. So to give you an example, let's say we're working on building a URL shortener like bit.ly or tinyurl. When you understand the parts, you can work with an engineer on an architecture diagram like this. You can come prepared with both functional and non-functional requirements. Functional ones would include, given a URL, our service should generate a shorter and unique alias of it called short link. And this link should be short enough that it can be copied. And then when users access that short link, our server should redirect them to the original link. The non-functional requirements might look like the system should be highly available. This is because if our service goes down, the URL redirections start failing. Redirection should happen in real time with minimal latency, etc. And there's so much more. There's just a couple examples. And as you can see, this makes a huge difference. Now you're speaking the same language. You can make better trade-offs because you're doing it collectively. So what can you do to start improving your technical abilities? First, no matter what you do, I want you to know this might be a struggle. In the beginning, I struggled a lot. Turns out that creating mental models, holding things in your head, imagining data traveling through a system, boils down into one skill called spatial reasoning. So I started looking into this problem more because it turns out that this skill was the source of my frustration. I had terrible spatial reasoning skills, and I still work every day to improve this skill. Spatial reasoning is the ability to generate, retain, retrieve, and transform well-structured visual images. It's what we do when we visualize shapes in our mind's eye. There's a ton of academic research that says spatial reasoning is the key to a career in STEM, yet a lot of women and underrepresented minorities lack this skill. Why? Well, from my own experience, when I was a young girl, I didn't get blocks or Lincoln Logs, and my Black single mother did not do origami with me. I got dolls and Nickelodeon, so I was really behind. And you might be one of the lucky few that happens to be amazing at this. If not, you're not alone. It's something you can get better at over time. Either way, there is no other way to get a large-scale code base in your head than to force it in there using spatial reasoning. So I highly recommend you assess your spatial reasoning skills if you're having trouble learning engineering. So I'm sure by now you're thinking, I thought you were going to tell us how we're going to get better. So I will do that now. So what can you actually do? You can do what I did. You can get a second bachelor's in computer science. 2 things that you should know. I found this to be more valuable than a boot camp because boot camps tend to not give you the same understanding of a large scale code base. And 2, turns out you can't get a second bachelor's degree in California, but you can in Maryland and other states like Oregon, and you can take your classes online so you can still maintain your a job. Or you can study the things required to pass a system design interview. The best system design interview program that I found is on educated.com, grokking the system design interview. I would read and look up all of it, starting at the basic problems and adding on. Some of the things I would specifically focus on if you're short on time are goals and requirements of the system, system design requirements, the basic and the high-level system design, API requirements, so you can see and understand what kinds of data goes in and out of the system, and any large concepts that you're unfamiliar with, like load balancing, data sharding, caching, reliability, security, etc. I would also read a lot of code. This is actually what a lot of people advise, But here's what I do. I put it on my calendar. I go to Stack Overflow or I go to open source code base. And the best advice I got was from a language teacher. So you read it over everything, all the things that you don't know. Then you read it again, noting down the things that you don't know. Then you look up all the things and then you read it again. And hopefully that helps you to bridge the gap between what you do know and what you don't know and how you can fill in the spaces. You can reason about the data. So the system, if you recall, is made up of code and data. So if you're only looking at the code, you're actually missing half the picture. So answering questions like, where's the data stored? What does it look like? Where does the data start, go, and end up? And how is it transformed along the way? What parts of the system have access to the data and which parts don't really gives you an understanding of not just the system, but how data transforms throughout the system as well. In our Bitly example, a user can give a long URL. They may generate the short URL, but our system might also transform the long URL into the short URL. Then the system stores both along with an expiration date and then tells the user about the short URL. They transform the long URL into the short, right? So sometimes that bit might be a short algorithm and sometimes that is an entire system. But zoomed out, you might see only the same picture. You can also just bug an engineer to tell you more things. Note here that try to do this after work, over coffee, etc. Because if they're talking to you, that means they're not coding your product. So I'm not gonna lie, these practices aren't always fun if they're not natural to you, but it's so worth it. And I'd like to make this journey easier for you today by letting you know it is worth it, that it might be hard, but it definitely gets easier. And there are concrete strategies to get there. Having gone through this experience personally, that's how I actually came up with the idea for CodeSee. If any of you are curious, here's the website, sign up for the beta. I would love to get your feedback. In a nutshell, what CodeSee does is it helps development teams speak the same language. It takes our large-scale systems that engineers have traditionally held in their heads and creates a visual map along with all of the data that a PM can understand. And it shows them how all the pieces fit together so you can actually make better products. This map shows you everything from the line of code that gets run all the way to the high-level system architecture. So let's go back to our Bitly example. You're a PM and you want to change how the sign-up flow works. You could literally use CodeSee, hit start, go into your sign-up flow, and it'll provide you with what we call a data flow, which is a code execution map to tell you every function that got called, every service that was called, and all the side effects of that system. You could attach that data flow to your ticket, and for the first time, your engineers will know exactly what to change and how to change it so that you can get accurate estimates and your engineers would be much faster. And then this is life-changing. Having been on this journey, here's what I know for sure. That each of you has this untapped potential. With more technical knowledge and skills, there's no question in my mind that you can get better jobs, build better products, communicate more effectively with your engineers, and more. So I invite you to look into becoming more technical, whatever that means for you, not only in service of your own growth, but also in service of all of us collectively as women in product and the lives of the customers that we touch. My wish for you is that for none of us to ever have to be told that we're not technical enough ever again. Thank you.
Thank you, Shanea. Next up, please welcome Anu Ramakrishnan, Principal Product Manager, Roche. Anu is product manager in the digital health industry who is passionate about improving the patient and provider experience through technology. Her expertise lies in launching software products like mobile and wearable apps, provider portals, and AI algorithms. She is currently at Genentech, a member of the Roche Group, where she focuses on developing digital health solutions for oncology. How awesome is that? Prior to Genentech, Anu worked on scaling a smartwatch-powered virtual health platform for cardiac care at Samsung Health. Anu believes in a human-centered design approach to building products and in testing early and often. She will share her expertise with us during our next presentation, PM Hack Being Nimble with User Testing. And I can't wait to learn to do more awesome user testing in our new remote world. So let's get started with upleveling your technical skills.
Hey everyone, thanks so much for tuning into this talk today, and I hope you're all safe and sound wherever you're at. I'm Anu Ramakrishnan, and I'm a digital health product manager based here in the Bay Area. I have a lot of experience building and shipping apps for both software and hardware intended for improving patient care. I'm currently a principal PM at Roche, which is a big pharma company, where I lead digital health products for oncology. Prior to that, I was a PM at Samsung Electronics, where I led and scaled a B2B digital health product for virtual patient care. One of the things I've learned over the years and feel very passionate about as a PM is product design and user testing. And how might one be able to prioritize testing when you don't have a ton of budget, time, or resources available to execute? So I wanted to share some of my hacks for nimble and agile ways to perform user testing that I've tried and tested in the past, so that you, as a product manager or an entrepreneur, can easily adopt these to vet out your product features before you launch. So without further ado, let's get started. So before jumping into hacks, I think it makes sense for me to talk a little bit about a typical user testing framework. Typically, you'll identify the need for user testing when you either have a brand new product concept for an app, or when you have something more specific, like an improvement to an existing feature that you'd like to test. So first and foremost, it's really important to make sure that you scope out exactly what your product team intends to test out, and also get this reviewed by your cross-functional teams. This ensures that you stay focused on your goals and metrics, the hypothesis that you want to test out, and also how you plan to run your experiments. Once you've determined your scope, it's imperative to ensure that you're identifying your target user segments. This is especially important if you're designing a product or a service that caters to multiple types of customers. Your target user segments will obviously involve people you've designed your product or feature for, but more specifically, you might want to go after some unique personas or extreme users who you're most curious about from a usability point of view. The next steps involve actually finding or recruiting these users and running your tests, which I'll talk more about shortly. Lastly, by analyzing your results, which could be a mix of both quantitative and qualitative data, you can make a decision as a PM as to how best to iterate upon your designs while optimizing for your product metrics. Now, the steps that I typically find the most time-consuming, cost, and resource prohibitive are recruiting users and actually running your experiments. As a PM, I've often found myself in situations where I've had a lot of constraints with regard to budget or time, because of which I've either had to rely on intuition, which is far from ideal, or on the flip side, found great opportunities to find creative ways to still get the tests done myself despite all of these constraints. So I'd like to share some of these hacks with you all. Now, typically, user researchers tend to work with external recruiting agencies to find users. And while this is standard practice, there are a ton of challenges around negotiating your selection criteria, waiting for responses, and coordinating schedules. This can cost a lot of money, time, and also require a ton of legal paperwork. So why not directly meet users where they are? I've had several instances in the past where I've rallied my teams to take our prototypes to folks in libraries, coffee shops, and even leveraged employees at my company as well as others to gather quick feedback. Some of the many advantages, besides being free and quick, are that you can easily control for bias, overcome no-shows because you can literally keep testing until you reach your sample size, and have yourself or literally anyone on your team run these tests without any special skills or experience. How great is that? On to the next step, which is actually preparing for your tests. Now, creating your designs and having your UX team put together an extensive click-through prototype and getting your engineering team to create an alpha version of your app is one way of getting ready for user test. But here are some alternatives that are not only quick and cost effective, but are also tools that literally anyone can use to put together a prototype. The first tool I have here takes us right back to the basics. You can literally sketch a prototype on pen and paper and use paper cutouts to manipulate interaction elements on your app like you see here. This is as nimble as it gets in putting together a working demo of your app. This is also great if you just want to test out early product concepts without making any commitments with your engineering or design teams. Now, if you actually have some designs of your app that you'd like to test out, but don't have a clickable prototype, or have a bit of a different form factor like a smartwatch, for example, that you need to work with, you can consider loading up the design images as JPEG files onto your device's camera roll. This is a great way to help your test users get better context into the actual product and can help you provide verbal feedback on the expectations around interactions and things like that. Now, taking it up just another notch, if you're really gung-ho on putting together a working prototype, but just don't have the skills or time to navigate a more advanced tool like Figma or InVision, here are some really simple and easy tools that you can use to generate click-through prototypes in minutes. Pop by Marvell is a great one that allows you to load up pictures of your designs and assign clickable actions within seconds. Well, that's pretty nifty, right? Lastly, I do want to acknowledge that in the COVID-stricken world we live in today, even these nimble strategies need to be adapted to some extent to deliver successful results. Particularly, you will have challenges around finding and reaching users, especially when we're all social distancing and working remotely. While finding users in a physical setting may still be feasible, albeit challenging, you can always leverage online resources like usertesting.com and 5-second tests to take your process completely online. Another strategy that I've been trying to pilot is adopting a hybrid model, especially when physical devices and elderly users are concerned. This involves only meeting your users in person to set up and onboard them onto your apps and devices, while practicing social distancing where possible, of course, and doing the rest of your test entirely virtually. This helps navigate some of the technical constraints around setup, while also making the test experience more personable and high touch. Well, with that, I'd like to thank you guys for tuning in today, and I hope you found these tools helpful. Thank you, and happy testing.
Thank you, Surbhi, Shanea, and Anu, and all of those who have joined us live. If you'd like to connect with our speakers, they are available for Q&A and roundtable discussions in our interactive sessions at 11 a.m. PST. You can find the sessions on the side navigation of the Hop-in window, and I hope all of you are living and breathing that app. That's where our conference is happening, and you can interact with people. Coming up next on this stage, join us for Alternate Routes, Rethinking the Roadmap.